Hey y'all, today we're going to talk about comparing functions. And the first thing I'd like for you to do is, if you're taking notes, go ahead and grab a sheet of paper, get your paper ready, hit pause, get it ready. All right, hopefully you're back. Have out your week 5 comparing functions sheet that you received in your packet or that you picked up from LMS. So let's look at number 10. Compare the rate of change and initial value. So you need to make sure you remember rate of change is the same thing as slope. So let's just write that down. Rate of change is the same thing as your slope. Now, you need to always make sure that you break it down to the unit rate. Break the slope and that rate of change down to 1. You can't really compare things if you're dealing with one item in a particular problem or 2 or 3 items in a different problem. You need to always make sure your graphs, your tables are always going by increments of 1. If they're going by increments larger, you need to make sure you break it down so that you're comparing on an equal playing field. Let's go ahead and look at number 10 on your sheet. So I'm going to go ahead and slide this over. Let's look at number 10. So function 1. If I have a starting point right here, that's my initial value. So I'm starting at 2. I need to find a lattice point to help give me that rate of change, that slope. So how much up and over does it go until it gets to another lattice point? That is not a lattice point because it's in between. That is a lattice point. So this goes up 3 over 2. So what is my rate of change for function 1? All right, so the rate of change is going to be 3 over 2. So if you get ready to write this as an actual equation, it's going to be y equals 3 over 2x plus 2 because it started at 2. So now we need to look at the rate of change for function 2. We're going to compare function 1 to function 2. Aaron charges an initial service fee of $10 plus $15 per hour. Now, don't get confused and plug 10 in because you see that number first. You need to know how to read word problems. Per hour, each, every. Words like that are indicators that that number goes with the slope, the growth. So let's go ahead and write an equation for this particular word problem. So Aaron charges an initial service fee of $10. This is going to be for function 2. Okay, so he has an initial fee of $10. That means before he even charges any money at all, he has $10 coming in. So if we're setting up a y equals mx plus b, your starting fee, your initial value is always that b. So the rest of our problem says plus 15 per hour. That keyword per tells you that 15 is with your x spot. So 15x plus 10. So 10 is your initial value and 15 is your starting point. Now you can compare the unit rates, 3 over 2 and 15. 3 over 2, if you divide that out, you get 1.5. So which is greater, 1.5 or 15? 15 is greater. So anytime you're comparing unit rates, you always break it down to 1. I hope this helps. Y'all have a great day. Bye.